Right, so today we're going to look at section 1.5, which is on quadratic transformations. What's kind of nice about transformations is whether you're doing transformations on parabolas, which is what we're going to do today, or transformations on square root functions, or transformations on anything, they all work the same. So once you know how to do transformations for quadratics, parabolas, you'll know how to do it for any function we're going to study all year. So, in general, a quadratic function looks like this, in the form ax squared plus bx plus c. And a, b, and c can be any real number that you want. That's just basically what that says. This symbol means, if you want to be specific, an element of, or part of. So a, b, and c are part of the real numbers, which means positives, negatives, fractions, decimals, and 0. The only thing on a, you've got to be careful, there's one number that a is not allowed to be, and that's 0. Because if you had a quadratic and you filled 0 in for a, 0 times anything is what? 0. So if you did 0 times x squared, you would wipe out the x squared term. Now all you have is bx plus c. That's kind of like mx plus b. All you have is a line now. You just wiped out the square term. So a can't be 0, but it can be anything else. Okay. And b and c can be anything you want. Right. So if we graph y equals x squared, you can graph it or you can just look at it. It's nothing we haven't graphed before. So if I graph just x squared and hit zoom 6, I get that U shape. And I said it earlier, but what's the name of that shape? Yeah, it's a parabola. So y equals x squared, I'll just put it over here so we can see it. Make it a little smaller. Okay, so that's what y equals x squared looks like. And now, what I'm going to do is I'm going to change x to negative x. Remember, when you see this notation, it just means take what's inside there and plug it in. So like if I asked you to do f of 2, you would take 2, plug it in, and see what you get. Well, let's try it with negative x. Let's plug in negative x instead of x. So let's do it. Let's do it like this. Negative x squared. And depending on where you put parentheses, that kind of makes a difference. Whenever I plug something in, I always like to put in parentheses, just because it usually helps kind of clear it up a little bit. So let's do negative x squared. Now let's just try it like that. Let me show you what happens. If you do it like that, it ends up upside down. So basically what that negative did is it flipped it. Now, if you put the parentheses in the wrong spot and you do something like this, negative x squared, or you put them in a different spot, I won't say it's the wrong spot. Let's see if that made a difference. Made a big difference. All right, so that's putting them in a different spot. So what this problem wanted us to do is what I had the first time. Okay. So I had them. Let's see, how did I have it? I had them on the outside. Right. So that negative, or basically throwing a negative in front, causes the graph to flip over the x-axis. So there's the original, and then the negative one's coming up right now. There it is. Right, and I think I write that down right below it. No, not yet. But any questions on the fact that it flipped just by putting a negative in front? And that's true for any graph. If you take the square root of x and you throw a negative in front, exactly the same thing would happen. The negative would mirror image your graph over the x-axis. Now, for a parabola, especially the two that we drew, the y-axis is a line of symmetry. That means if you took that, if that was like a piece of paper and you folded it right on the y-axis, the left half of the graph would land right on top of the right half. This particular, well, at least the graph in blue, contains a low point right here. And that low point is the vertex. Now, the vertex isn't always the low point. In the red graph, if you look at that one, the vertex is the high point. So it depends. If you flip the graph over, it might become the highest point. Okay, but that's the name of the highest or the lowest point in a parabola. It's called the vertex. Okay, any questions on that? Okay, so what we're basically going to do is just play around with the numbers in A, B, and C and figure out what happens to the graph. Does it stretch it out? Does it make it skinnier? Does it move it up and down? Okay, what happens? We're going to start by just focusing on one number at a time, because if you change too many things at once, you can't figure out what's happening. So we're just going to play with the number in front. Okay, let's graph the original, y equals x squared, and then let's try putting a 1/3 in front and see what happens. So I'll leave the original. I'm going to put in 1/3. That's how you can type it in. And then x squared. So remember, blue is the original. Red is going to be the new one. Okay, how would you describe what happened there? Yeah.
It wider.
Yeah, it got wider. And the reason it got wider is, imagine like that x-axis is like a floor, right? And that thing in blue was something flexible, like you could bend it. Well, if you push down on the thing in blue, if you had like silly putty on the table and you push down on it, what happens? It squishes out, right? Or you got dough or something, right? You're cooking, you push down on it, it squishes out wider. That's exactly what happened to the graph in red. We can think of it as it compressed vertically. It got squished down, and that causes it to get wider. Okay, so the graph in red got squished vertically, or you could say compressed. Let's try putting a 2 in front. You don't really need parentheses. I just had them from the last part, but you don't need them at all, so you can leave the parentheses off. So a fraction caused the graph to squish vertically. The 2 is going to cause the graph to stretch. Again, imagine that the vertex was glued down right at the origin, and you took the two sides of the parabola and you pulled up on it. Well, what would happen? If something was stuck to the table, like something sticky, and I pulled up on it, it would get long and skinny. It would get skinnier. So that's what's happening to the graph in red. It's being stretched vertically, so it gets skinnier. Stretched vertically. Any questions on the two things we just did there? Okay, so let's write down what we just said. So the effect of changing A, it does something vertical to the graph. Either stretches it or compresses it. If you put in a number bigger than 1, okay, like I did 2, but if you put in a number bigger than 1, the graph will stretch vertically. The bigger the number, the more stretch you get. If you put in a fraction, we'll just stick with positive fractions for now, but if you put in a fraction between 0 and 1, like 1/3 or 1/2, it's going to cause the graph to shrink down, or you could even just say compress. So the graph is shrunk or it's compressed vertically. The closer your fraction gets to 0, the more compressed it's going to get. So if instead of 1/3 you did 1/10, that would make the parabola even wider. Okay, so any question on what the effect is if you change a, which is the number that's in front of the x squared? Okay. So now, let's kind of combine this with what we just mentioned. Maybe we don't need to graph them again, but what happens when you throw the negative in front? That causes the graph to do what? Flip. Flip over which axis? The x. So what's happening in all of these, well, not the first one, but the second one and the third one, there's two things happening. This is causing something to happen. This is causing something else to happen. That is causing a vertical stretch. That is causing a reflection. So you want to think of the negative and the number as two separate things. Okay, we're going to write that. We'll talk about this right now. So the negative, this is what I said I had written down, but it came a little later than I thought. The negative causes the graph to flip over the x-axis. In other words, it opens down instead of opening up. Okay, so let's look at this one. You'll definitely see some problems like this on the test, where it basically gives you a graph, and it asks you, what did you do to this graph from the original? Okay. Sometimes we call the original the parent function. It's the simplest function where you haven't done anything to it. And then this one has been changed. First, the one that's in the box, let's just identify how many things are happening here. Right, so Nick, how many things are happening in the graph y equals negative 5x squared if you compared it to y equals x squared?
It's being flipped.
You don't have to tell me what they are yet. Just how many things are happening.
2 things.
2 things. Yep, I agree. 1, 2. And let's start with what's closest to the x squared and just kind of work our way out from there. So we'll start with the 5. What is the 5 going to do to the graph? Shai?
It stretches it out.
Stretches it which way?
Up.
Up, vertical. So the way we're going to write this down is we're going to say we have a vertical stretch, and just say by how much. It's vertically stretching by a factor of 5. So it's becoming 5 times as tall. So vertical stretch by a factor of 5. And then the negative, we just talked about that. What does the negative do? Reflect it, flip it over the x-axis. So reflect, but you got to be a little more specific than just reflect, over x-axis. And that's what they're looking for. If you're wondering, is there a certain order you should list these in? Yes. They are in the correct order here. I'm going to show you what the order is in a little bit, after we talk about shifting up and down and shifting left and right. It's kind of like PEMDAS. If you do it in the wrong order or you list it in the wrong order, it messes you up. Okay, so I'll talk more about order later. It's just a reminder to me. But any questions on the 2 transformations? Okay. All right, let's look at this one. This one's a little different. We're not multiplying by a number in front of x squared. We're adding a number onto the end of x squared. So let's try it. Let's graph y equals x squared, and then y equals x squared plus 2. And actually, before I hit graph, does anyone have an idea of what the plus 2 is going to do? Yeah, Nick?
And make it move left by 2.
Okay, you think it's going to move left 2? Anyone have any other thoughts what could happen? Yeah. Up 2? Yeah, it's definitely going to be a shift. Okay, it's not going to stretch it. It's going to move it 2 units. Let's see what direction it moved. Okay, so there's the original. And there's the new one. So it did move up. It shifted everything up 2. So if plus 2 shifts up, minus 3 is going to shift down. So if I did minus 3, we can look at it. And it's not super interesting, but you can see it. There's the original. And now the vertex in every other point has been shifted down 3. Okay. So let's write out what they want to know. So to get y equals x squared plus 2 from the parent function, from the most basic parabola you can have. So to get y equals x squared plus 2 from y equals x squared, we want to shift y equals x squared up 2. Okay, and then to get y equals x squared minus 3 from y equals x squared, shift the original down 3. Okay. So what we've just seen is that adding and subtracting a number onto the end will cause shifting up or down. So let's write that down. So these are vertical shifts. Okay. Any shift is what we call a rigid motion transformation. Rigid means that you're just taking what you have and you're just moving it somewhere else. You're not stretching it or distorting it. You're just taking it and moving it. So if you add a number onto the end of a function, we'll call that number k. If you add a number that's greater than 0, that'll shift you up. How much? Well, it depends on what k is. Up k units. If you add a number that's less than 0, that will shift you down. Now, why did I say shift down absolute value of k units? If k is less than 0, why not just say shift down some number less than 0? What's kind of awkward about that? Yeah?
Because if you say it's shifting down -2 units, it seems like you're actually going to move up with it.
Yeah. The word down takes care of the negative. Right? You wouldn't say you shift down -2 units. You shift down 2 or you shift up 2. But you don't shift up and down negative units. That doesn't make sense. Down is the negative. Okay? So adding a number on the end shifts up or down. What do you think adding or subtracting a number inside the parentheses is going to do? Okay?
Move it left to right.
Move it left to right. So let's see what happens. Any guess which way the minus is going to shift it? Left? All right, let's try it. So x minus 3 squared. So there's the original, and then a minus actually shifted it right. So this one's a little weird. It's kind of the opposite of what you would think. Minus shifts right. Plus would shift left.
Why is that?
It's kind of like if you had an equation like x minus 3 equals 2. You know how you have to do the opposite to both sides to solve it? That's kind of like that. It's like you're doing the opposite operation. You'd have to add 3 to each side. And that's kind of how I think about it. I say to myself, all right, what would I have to do to change that back to x? I would have to do the opposite. I would have to subtract 2, which would move it left. Okay? If I look at this one, I would say, all right, to get rid of the -3, I would do the opposite. I would add 3. And that adding would push it to the right. So, yeah, it's just a little weird, but we'll try to come up with a way to remember that. So to get x minus 3 squared from y equals x squared, shift y equals x squared, right 3. Okay, so that was the first one. And the second one, to get y equals x plus 2. Again, you don't have to write this if you don't want to, because we're going to have a rule for horizontal shifts in a second. I'm just trying to show you 2 specific ones. Y equals x squared. You're going to shift. Plus does the opposite, so left 2. Okay, so these are both examples of horizontal shifts. Again, another rigid transformation, meaning there's no stretching, just taking what's there and moving it somewhere else. So if you write your horizontal shift as x minus, okay, if it's always written as x minus, and then you block the minus sign and just look at the number that's after the minus, pretend, block everything else. So you get kind of like getting rid of the negative. The number after the minus sign tells you which way to shift. All right, so if we go back up to what we had here, that's the number after the minus sign. Block everything before it. All I see is a 3. 3 is going to go to the right. Okay? Because that's all that's there if you block everything before it. It's just a 3. And 3 on a number line is to the right. I'll come back to the other one in a second. So if you block the x and block the minus, look at what you haven't blocked. What's in the box. If what's in the box is bigger than 0, you're going to shift right. Now, let's look at x plus 2 squared. I said if you write it as x minus. How can you write x plus 2 with a minus? Yep.
X minus -2.
Exactly. X minus -2. Now, let's do the same thing. Block the x minus. Okay, block it off. Pretend it's not there. Look at what's left after it. A -2. -2 is going to shift left 2 units because negative goes left. So that's how I try to think about it. Look at your parentheses. Look at everything that's before the box and block it off. Block off the x and the minus, and whatever's left in the box is either going to be negative or positive. Okay, so it's a little tricky, but if you try to think of it that way, just block the x and block the minus. Whatever comes after it, that number tells you which way to shift. And same idea. We don't want to say shift left negative units. You can shift left or you can shift right, but it's always a positive number. So now that we've talked about shifting left and right, what we can do is we can find the vertex. Because remember, the vertex starts, I don't know if I have the original still, but the vertex is always at the origin unless you shift it left and right or up and down. Well, H controls shifting left and right. K, the way I labeled them, controls shifting up and down. So if you want to find your vertex after you've done a shift, that is your vertex. it's h comma k. H is the number after the minus sign. K is the number at the end. And we're going to practice that. I'll give you an example and I'll just say, what is the vertex? So you just have to say, okay, how much did I shift left and right? And then how much did I shift up or down? And that tells you where the vertex moves to. Now, the line of symmetry. For a parabola, which way does the line of symmetry go? Left and right or up and down? Up and down. There's your line of symmetry. Now, if you shift the line of symmetry up or down, does that have any effect? Think about a line. How long is a line? Infinite. So if you take a line that goes up and down forever and shift it up one, does that change it? No. So shifting up and down has no effect on the line of symmetry. The only thing that affects the line of symmetry is if you move it left or right. And that value is controlled by h. So the line of symmetry, after you've shifted it, is x equals because it's vertical. And then how much did you shift left or right? So x equals h. If all you do is shift up or down in a problem, you haven't changed the line of symmetry at all. Think about it like this. You shift it up, same line of symmetry. Okay, so let's look at an example. We want to find the vertex and the line of symmetry. So just a reminder, what were the two letters for the vertex? It was what, comma, what? Yep.
H, comma, K.
H, comma, K. H is the number after the minus sign in the parentheses. K is the number at the end. Now, I don't have a minus sign in parentheses. I've got the plus, so I want to be careful here. How could I think of that as a minus instead of a plus?
-2.
Minus -2. Now, h is the number after the minus sign. There's your minus sign. There's the number that comes after it. So you've shifted left 2. And what other direction have we shifted besides left 2? Okay?
Down 3.
Down 3. So the vertex, instead of being at the origin, is now left 2, down 3. That's the vertex. Okay, line of symmetry. Carolyn, my equation for the line of symmetry, since it's vertical, always starts out with what letter equals? Yep, perfect. It's always going to start out x equals. And in this case, Alec, it's going to be x equals -2. It's the same number that's right there. It's x equals h. And that's it. That's your vertex and line of symmetry. Questions on that one? Okay. All right, so another problem, kind of like what we did before. I just want to know what transformations are happening to change the parent function into 5x squared plus 4. And the order matters. And if you're wondering, well, how does it matter? Think about a number. Pick any number you want in your head. Multiply it by 5 and add 4. Take the same number you were thinking of and do it in reverse. Add 4 and then multiply by 5. You don't get the same answer. Okay. So it makes a difference. So I'm going to put up, what I would do is leave like, this is going to be 2 lines here. So leave maybe 3 lines or so. And then below that, we'll come back to it. This is the order to always do the transformations in. Okay. Always deal with the horizontal shift first. That's the number that's added or subtracted in parentheses. Then deal with the vertical stretch or compression. That's the number in front of the x squared. And these are all if necessary. So I'm not even going to put if necessary after that one. They're all if necessary. You don't necessarily have every one of these in the same problem. Okay. After you deal with any vertical stretches, then you deal with any reflections. How would you know you have a reflection? You got a negative in front of the x squared. And then the last thing is your vertical shift. Could be up or down, and that's the number at the end. Okay, so let's look at this one and write down our two transformations. Okay, I'll kind of guide you through the first one, and then I'll let you guys kind of try the second one. All right, so first thing, I look for horizontal shifts. I'm looking at that, and I say, nope, there's no adding or subtracting in parentheses. So then vertical stretch. I'm looking for a number in front of x squared. Yep, I do have a number. So I have a vertical stretch by a factor of 5. Okay, then the next thing is I look, do I have a reflection? Nope, there's no negative in front of the 5. So keep going. I look for vertical shift. Yep, I got a +4, so that's a vertical shift up 4. And that's it. Those are the steps for describing the transformations. Okay, let's try this one. And looking at that one, anyone think they know how many transformations are happening?
4.
Yep, there's 4 things happening, so basically all of them. Anyone tell me the first transformation? Connor?
It would be a horizontal shift. It would be to the right one.
Yes. So look at the number after the minus sign. It's a 1. 1 goes to the right. So shift right 1. First one. Second thing. What's the second transformation that's going to happen? Well, Nathaniel?
After shifting right 1, we're going to do the stretching or shrinking, so that's going to be multiplied by 3.
Yeah, it's going to be a vertical stretch by a factor of 3. Third thing, do we have a reflection here? What do you think about Sam? Do we have a reflection?
Yes.
Yep, how do you know that?
The negative sign.
Perfect. So now reflect over x-axis. And then the fourth thing, the last thing, is the +4, and that's going to be a shift up 4. So that had everything. For parabolas, you really can't get any more complicated than that. It's got them all. Okay, good question on that. All right. So we're going to look at one problem that's written more like this. 3x squared plus 12x minus 18. It's not written the way we like to see it with parentheses. Okay, the way you want it is with parentheses. The problem I'm about to show you, it's almost like if somebody took the x minus 1 squared, foiled it all out, and then distributed a -3, and then added 4 and combined like terms. That's how you would end up with something like this. You don't want that. If you get something like that, we have to fix it so that it's more like the problems we've been looking at. Okay? The problems we've been looking at, it's called standard form. And standard form makes it super easy to see the shift left and right, up and down, and any stretching you're doing. So if you have an equation that's not in standard form, we have to complete the square. Okay, so I'll show you on this one how to complete the square. It's something you do towards the middle to end of Algebra 1 when you do quadratics. When you do quadratic formula and factoring. But we'll go through it just in case anyone doesn't remember. The biggest thing when you're solving any equation, just make sure you keep it balanced. Whatever you do on one side, make sure you do it on the other. Now, in Algebra 1, I would spend a whole day on completing the square. I would teach the whole lesson just about that. So we're not going to spend a whole day on it. We'll spend about 5 minutes, since you probably already did it at one point, and it might kind of come back to you. Is everyone good on the left so I can make the right bigger? Okay. All right. So the first thing you want to do to complete the square is basically write down your equation and just change y to 0. Okay, you just want to get your equation equal to 0 to start. This one already had everything on the other side. X squared, the x, and the number. So that's fine. So I start with that. Put everything on one side, get 0 on the other. And that's what we have right here. Now, the next thing you want to do is put the constant on the other side. Some people do that right away. They just skip right to that step. If you want to, you can. But put the constant on the other side. So that's the first thing. Put the constant on the other side. Next thing, to complete the square, that number can't be a 3. It has to be a 1. So the 18 is just going to kind of hang out there for a while. It's on the other side. But does anybody see a number that I could factor out of 3 and 12? So when I factor it out, I end up with just x squared instead of 3x squared. Yeah. Yeah, factor out basically whatever number is in front. And leave a little bit of space, because now we're going to complete the square. So let me double check it. 3 times x squared. Yep. 3 times 4 is 12. Yep. So I factored out a 3, and now we just have a 1. You don't have to write the 1. Okay. So now to complete the square, and again, if you don't know this part, you might want to write down what we're doing. You do 2 things to that number. Step 1 is to take half of it. So you take half of the number in front of x. And then square it. So take half of the number in front of x and then square it. So let's try that here.
Just adding and then squaring.
Yep.
You pick the best number for that.
Yeah, well, yeah, when you have the number 4, you don't really get something very interesting. Half of 4 gives me 2, and then when I square it, 4. That's why I said you might want to write down what we did at that step. If it was 6, then you'd get something more interesting. But 4, it ended up staying the same. Now, we've got to be careful, because we just added something to the right. We can't just add something to the right. We also got to put it on the left. But be careful. What did we add on the right?
Yeah, 4, but it's also being multiplied by 3.
Right.
So we added 12.
We really added 12 on the right, because we have a plus 4, but that 3 gets applied to everything that's in the parentheses. Don't do it out. Just leave it like that. So we really added 12 on the right. To keep it balanced, you've got to do 12 on the left. That's the part where most people make a mistake. You don't always have to factor out a number in front of x squared. Sometimes it's already a 1, and that's easier. But this is like the worst case. You got to factor it out, and just don't forget that you really added 12. All right, now this should factor very nicely because of that special number that we added. It's going to factor into something times something, and they're going to be the same, like x minus 5, x minus 5, or x plus 6, x plus 6. Does anybody see what this factors into? Shai?
Is it plus 2?
It's x plus 2, x plus 2. And instead of writing x plus 2 parentheses and then another one, I'm just going to write x plus 2 squared. Now I'm starting to get something with parentheses. So now I can see a horizontal shift of 2 units. I couldn't see that before in the original problem at all. I had a 3, a 12, and an 18. Can't really tell. So the last step is basically get it equal to 0 again and change it back to y. So you have 3 x plus 2 squared minus 30. Now I see a vertical shift of down 30. Didn't see that originally at all. And just change it back to y. Okay, so when you have to complete the square, it is a little bit of extra work. But now I can see, all right, I've shifted. You can write these down if you want. I'm not going to write them. I've shifted left 2, vertical stretch by a factor of 3, down 30. Can't tell that at all from the original problem. And we can practice tomorrow with the homework. We can practice another completing the square if we need to. Any questions on that? So I think this is the last thing. So we've talked on the calculator a little bit about this, finding the zeros of the function. That just means where it crosses the x-axis. That's all that a 0 is. It's a spot where it crosses the x-axis. And does anybody remember where that was to calculate a 0? How do you get to that button?
Isn't it just second and then calc?
Yeah, it's just second calc and calculate a 0. So basically, it's a number you plug in for x. And when you plug it in, you get 0 for y. That means that's where it crosses the x-axis. Now, how many times can parabolas cross the x-axis at most? Twice. So, could have something like this. Could they cross just once? Yeah. That's like the parent function, right? It just comes down, touches it, and goes back up. So it doesn't really cross it, it just kind of touches it. How about, could it not cross at all? Sure, if you took your parabola and shifted it up. So quadratics can have 0, 1, or 2 places they cross the x-axis, which those are called the zeros. And there's a very quick way to tell how many times a graph crosses the x-axis. And it has to do with that calculation right there. Now, if you don't remember, like, what's A, B, and C? A, B, and C are coming from right here. A is in front of x squared. B is in front of x. C is the number at the end. Now, does anybody recognize that? B squared minus 4AC? It's part of something else. Yeah? It's part of the quadratic formula. Specifically, it's the part right here. It's the part that's under the square root. And if you take the part that's under the square root, b squared minus 4ac, and you figure out if it's negative, 0, or positive, that will tell you how many times it crosses the x-axis. Okay, let's look at the first case, where it's less than 0. That means this would be negative. What happens if you try to take the square root of a negative? It doesn't work. It doesn't work with real numbers. You get imaginary numbers. That means there is no place where it crosses the x-axis. That would look like this. Never crosses the x-axis. Now in the second case, it's where it comes out to exactly 0. Well, what's the square root of 0? 0. 0 times 0 gives you 0. That's okay. The brain power at this point, again, it's almost
Power 0 makes it 1.
yeah, 0, anything to the 0 power is 1. So there's only one answer to that. I asked you what's the square root of 0, and I got one correct answer. 0. Now let's pretend that it came out positive. B squared minus 4ac was greater than 0. What's a number greater than 0? 4. What's the square root of 4? 2 and negative 2. 2 answers. So if it comes out positive, there's 2 answers. Right? Now, what are the answers? Well, this doesn't tell you that. It just tells you that there are 2. If you want to find them, you either do the full-blown quadratic formula or use a graphing calculator. Okay. Oh, I didn't draw pictures, but here's one, and there's 2. 2, I mean, you can open up, you can open down, just crosses twice. Okay. Any questions on that? All right. So the homework tonight is a lot of different problems. So I didn't give you a big range of them. I just gave you one of each type to try. So it's 1, 2, 7, 10, 11, 16, 18, 21, 22, 28, 33, 40, 41, 44, and 60. Okay, so we'll take a look at that tomorrow. And then tomorrow we will finish chapter 1. Okay, we'll be done chapter 1.